Okay, here we have a little bit more challenging Kirchhoff example. You'll see that we have batteries in parallel, and that means that we cannot do an equivalent circuit here. There's no way to simplify this circuit by doing the equivalent resistors. We must do Kirchhoff rules because of the batteries in parallel, okay? I've already decided what direction I think the current is going to go. I've got I1 coming here to the right, I2 going out of the junction, and I3 also coming out of the junction down this third branch, okay? I'm going to start with a junction rule. Again, I'm going to do as many junctions as I can until I make a junction equation where there are no new variables. So I'm going to start here at junction B, and I'm going to say that I see that I1 is coming in and I2 and 3 are coming out, so they must add up to I1. Okay? If I go down here to this junction E, you'll notice that again I have I2 coming in, I3 coming in to make I1. If I do this junction, it'll have the variables I1, I2, and I3. None of those are new. They've all been used before in the first equation, so this junction is redundant. Now, it looks like I have three variables, and the three variables are I1, I2, and I3. So with three variables, I need three equations. I have one equation from the junction rule, so now I need to have enough loops to make three equations. So of course I need to do two more loops. I'm looking at first putting the high energy side and the low energy side on each of these resistors and batteries. The batteries are simple. You have a minus terminal and a plus terminal, minus and plus, minus and plus, minus and plus. For the resistors, I need to see what direction the current is going. So if this is I1, well, of course, through this resistor, current is going this way. And for this resistor, current is going up. For this resistor, current is going to the left. Current is going down. Current is going down here to the right, and then it's going to go. Let's see, if I've got I2 going this way, then it has to go over and down. So current is going down, and then it's going to be going to the left here to return to the junction E as I3. So these are I think I mislabeled this guy. This is I3 and this is I2. So here I2, 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 I2. Here going down the third branch is I3 and I3. And this is going to allow me to mark the high energy side and the low energy side of the resistors because they're going to use up energy as the current goes through. So for example, this little R1, high energy side is here, low energy side is here because the current, the charges are going to come in with more energy and they're going to get used up a little bit. And then they're going to leave this resistor with lower energy. So here, high side, high, low, high, low, high, low, and the current in this branch is going down. So we have high, low, just like that. All right. The next thing I'm going to do is figure out what direction I want to make my loops. I think the left closed loop, this one is pretty simple. I see that I1 and I3 here are going in a clockwise fashion, so it's probably simplest to just do a clockwise loop. So I'm going to start here at the battery, and I'm going to take my finger around this loop in a clockwise direction. So I'm starting at the 18-volt battery, and I'm going in the direction from low energy to high energy, so that's going to be a raise of 18. And then I get to the first resistor, and I'm going from high to low, so this is going to be a drop of the voltage drop on this resistor. Well, voltage is I times R. This current is I1, and this resistor is 0.5. So I'm going to say 0.5 times I1. Continue to go around in a clockwise fashion. I'm going from high to low, so this is another drop of 20 times I1. Continue to move around. Now I'm into the third branch with current number 3. And this is from high to low. It's a 6 ohm resistor and it has the current of I3. So it's going to be a drop of 6I3. I'm going to get to this battery and I'm going from low side to high side. So that's going to be a raise of 3. And with this resistor, the 0.25, going from the high side to the low side, it's a drop of 0.25 times I3. And the last resistor here, R4, I'm going from the low side to the high side. So this is a drop of minus 15, but I'm back to current number 1 because I've left the junction where I3 and I2 combined to make I1. And again, all of these are supposed to add up to 0. Okay, I've got one more loop that I need to do in order to get my 3 equations. So I look at this loop and I see that I2 and I3 diverged here. They went in opposite directions at the junction. So really a choice of clockwise or counterclockwise doesn't really matter here. Neither is the obvious choice. So what I'm going to do is I'm going to use this 24 volt as the strongest. It's the strongest battery. So I'm going to go ahead and start at the 24 volt and I'm going to go counterclockwise. That just makes the most sense to me because I've got this this number 24, which is the highest voltage. So if I'm going counterclockwise, I start at the 24. That's a raise of 24. And now I am going counterclockwise. So here, 0.75. Notice that I'm going from the low side to the high side because counterclockwise is against this current I2. So that's actually going to be a raise of 0.75 times I2. That's why it's really important to mark that minus and plus. Here, when I get to little r3, again, counterclockwise, I'm going from minus to plus. So that is also going to be a raise in voltage. So that's 0.5 times I2. When I get to this 12 volt battery, I'm going from the high side to the low side. So that's going to be a drop of 12. And let's see, moving up to the 8 ohm resistor from low side to high side, that's going to be also a raise, low to high. So that's plus 8 times I2. Okay. Let's go ahead, continue down through the third branch. Finally, when I get to this 6 ohm resistor, I'm going from high to low. So that is a drop there from high to low. That is minus 6. And in that branch, we have a current of I3. And then we are going to go through the 3 volt battery. I'm going from the low side to the high side, so that's going to be a plus 3. And the 0.25 ohm from the high side to the low side, that will be a drop of 0.25. So a drop of 0.25 times I3. I3. And remember, that is all supposed to add up to 0. Okay. I do notice here that I have 6i3 plus 3 minus 0.25 i3. That shows up in both of my loops. And again, that's because as I went down the third branch in the middle, I was going, in both cases, I was going down. So it makes sense that term appears in both cases, and it should match up. Minus 6 plus 3 minus 0.25. Okay. But what I want to do then is I want to simplify each of these equations a little bit. So let me take each of the equations and try to line them up in the way that I would to make my matrix. Okay, so it looks like the second and third equation are going to be the most challenging to simplify. So let's go ahead and combine like terms. I've got here, in terms of constant terms, I've got 18 and I've got 3. And they're both positive, so that's going to give me 21. And then I've got some I1 terms. So there's a minus 0.5, a minus 20, and a minus 15. Don't forget about this guy all the way here at the end. So 20, 15 is 35, and a half is 35 and a half. So this is minus 35.5 I1. Minus 35.5 I1. And then the last term is the I3. So minus 6 I3 minus 0.25 I3 is minus 6.25 I3. And again, that's all equal to 0. Now what I want to do is I want to move the constant terms to the right side, and I want to line up each of the variables. So I'll start with I1, and I'm also going to interject I2 into this equation, but of course the coefficient on I2 is just 0, and then I3. So what I'm going to do is I'm going to, instead of moving 21 to the other side, since it's already positive, I would move these guys over because they're negative. So I would add 35.5 I1 and I would add 6.25 I3, and I would end up with something that looks like this. 35.5 I1 plus 0 I2, right? The coefficient on I2 is 0. It doesn't appear in this equation. Plus 6.25 I3 is equal to 21. So now that equation looks good. I can stack up my currents I1, I2, and I3, and I have my constant term on the right. Let's do the same thing with the last equation. Constant terms are 24 minus 12 and plus 3. So 24 and 3 is 27, minus 12 is 15. So go ahead and do 15. And then the, looks like we have a new one here, is I2 terms, 0.75 and 0.5 and 8. So 8 plus 0.75 plus 0.5 is, that's 9.25 I2. And then the last ones are the I3 terms. So I've got a minus 6 and a minus 0.25. So that gives me minus 6.25 I3. And then it all adds up to 0. And again, I want to make this look almost in matrix form, which is to stack the currents and put the charges on, or so the constant terms on the right. So again, I've got a positive 15, so I'm not going to move it. I'm going to move these guys. I'm going to move these guys by subtracting 9.25 I2 and adding 6.25 I3. So that gives me 0 I1, there is no I1 term, minus 9.25 I2 and plus 6.25 I3 is equal to 15. So I've got three equations now. I1 minus I2 minus I3 is equal to 0. That's from the junction rule. I1 minus I2 minus I3 is equal to 0. I've got this guy, which is 35.5 I1 from the first loop that I did, plus 0 I2 and plus 6.25 I3. Okay, is equal to 0, is equal to 15. And then the last equation, which came from the final loop here, I'm sorry, is equal to 21. I don't know where I got 15 from. It's equal to 21. And the last equation from the second loop was 0 I1 minus 9.25 I2 plus 6.25 I3 is equal to 15. All right, great. So now I need to extract the coefficients and the constant terms and put them into a 3 by 4 matrix. So this is going to be 1, 35.5, and 0, minus 1, 0, and minus 9.25, minus 1, 6.25, and 6.25. And then our constant terms, 0, 21, and 15. And I'm going to go ahead and put them into my calculator as a matrix. So I go second matrix, and I want to edit because I'm adding a brand new matrix, and it is a 3 by 4. 3 rows by 4 columns. So this is 1, negative 1, negative 1, 0, 35.5, 0, 6.25, and 21, 0, negative 9.25, 6.25, and 15. Okay, and then I need to get out of here. I need to quit. So second quit, just to confirm that my matrix looks good, I'm going to go back to matrix, hit enter, and this is what matrix A looks like. It's 1, 35.5, and 0, negative 1, 0, negative 9.25, negative 1, and these 6.25s, and then 0, 21, and 15. So that looks good. So I am now ready to ref it. So second matrix, go over to math and down to ref. And I want to ref matrix A. Close the parentheses. It's going to go ahead and put those ones down the diagonal, and I get I1 is 0.38. I2 is negative 0.81. And I3 is 1.195 amps. Now, I really love this example because I did get a negative answer here. Now, what that tells me is not that I am wrong, not that the numbers are wrong. All that it tells me is to go back to your picture and say, okay, listen, I2 was not coming out of the junction. I2 was actually going into the junction. So I would go back to my picture and I would say, I messed up the direction of I2, but I know what the value of I2 is. The value of I2 is 0.81 amps. When you combine I1 and I2, you get I3. So go ahead and combine 0.81 and 0.38 and you get I3. Now this was probably obvious to a lot of you because of this 24-volt battery. This is the strongest battery in the entire circuit. I have the 24 and the 18. They are the strongest batteries in the circuit. So it would really make sense that the 24-volt is going to push current this way. But I purposely chose I2 to go in that direction just to show you what happens if you make a mistake and you choose the wrong direction of current. As long as you go through the problem solving correctly, it's going to fix itself in the end. It's going to let you know what the direction of that current should have been. So it's pretty nice as long as you can just trust the math and do the matrix pretty simply. Okay?